Hey guys, it's Andrew here. And in this video, we are going to be looking at question number 39 from the math test in test 2 in your red book. So flip to the math test in test 2, read question number 39, and once you've read the question, go ahead and hit play. Great. I love this problem. I'm a math nerd, all right? I studied math, I love math. This is about as meat and potatoes math as it gets. This is a problem that doesn't really require you to do any calculating. There's no equation to write. There's nothing to graph. There's no real math to do here. This is a purely content knowledge. This is almost like a trivia question. I love it. But this is dealing with some kind of upper level math, and a lot of you maybe have never heard of some of these terms before. And that means that you should not let a problem like this slow you down, trip you up on the math test. If you've never seen some of this stuff before, this is not going to be a low-hanging fruit problem for you, and this might be one that you skip on your first sweep or maybe even your second sweep through the math test. But for those of you who are math nerds like me and you want to learn a little bit about this stuff, you came to the right place. The question says, n and m are natural numbers. What set of numbers does their sum, n plus m, belong to? So in order to answer this question, you have to know what natural numbers are. You have to know what integers are. You have to know what rational numbers are. You have to know what real numbers are, and you have to know what complex numbers are. And you have to know the way they all relate to each other. This is some high-level stuff. Let's start by talking about natural numbers. There's a symbol for natural numbers, and it looks like this. It's like a fancy N. The natural numbers are what we call the counting numbers. They are positive whole numbers that you can count on your fingers, right? So the natural numbers are 1, 2, 3, 4, 5, 6, and so on forever. They are positive counting numbers. Those are natural numbers. And it tells us, that the problem says that n and m are in this set. They are both positive counting numbers. And it's telling us that we are going to examine their sum, n plus m. So just think to yourself for a second. If I was to pick any two numbers in this set, any two positive counting numbers, and add them together, what do I know about their sum? Like, let's say I pick 2 and 6. If I add 2 and 6 together, I get 8. Is 8 a positive counting number? Yeah. No matter what two natural numbers I choose, their sum will always be a natural number. You can't add two positive numbers together and get a negative number. You can't add two whole numbers together and get a fraction. So no matter what two natural numbers I pick and add them together, their sum will always be a natural number. Now this is really interesting because it's not enough to know that their sum is a natural number. The question also asks us about a whole bunch of different types of numbers, okay? It asks us about, I'm going to kind of draw this out for us. It asks us about natural numbers. That's that fancy n. It asks us about, this is the symbol for integers. It asks us about rational numbers, this fancy Q. It asks us about real numbers, this fancy R, and it asks us about complex numbers. And it wants to know, is n plus m, whoa! All right, sorry about that. Here we go. We know that n plus m is definitely a natural number. But the question also asks us about integers, rational numbers, real numbers, and complex numbers. Now, I could spend weeks talking about what all of these different numbers are. All these different number sets are. So I'm just going to very quickly explain them to you. Natural numbers are positive counting numbers. 1, 2, 3, 4, 5, 6, blah, 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 blah. Integers, this fancy z, they are both positive and negative counting numbers. So this is kind of interesting. Every natural number is also an integer. Integers are positive and negative counting numbers. Natural numbers are positive counting numbers. So every natural number is also an integer. This fancy Q is rational numbers. And a rational number is any number that can be expressed by two integers divided by each other. A fraction with an integer in the numerator and an integer in the denominator is a rational number. Every integer is a rational number. And since every natural number is also an integer, that means that every natural number is an integer, is a rational number. Now, real numbers are any number that is a real number. I don't really know how else to put it. You've heard of complex numbers before. We're going to talk about complex numbers in a second. Some people call them imaginary numbers. Any complex or imaginary number contains I, the letter I, which represents a square root of 1. You don't need to really know that right now, but what you do need to know is that every rational number is a real number. And since every rational number is a real number, every integer is a rational number, and every natural number is an integer, that actually means that the set of real numbers, once again, contains all of these other number sets in it. And finally, we have the final number set that the question asks us about, the complex numbers. Now, the complex numbers are the set of all real numbers plus every number that contains the letter I, the square root of 1. So, complex numbers, the set of all complex numbers, actually contains the set of all real numbers, which contains the set of all rational numbers, which contains the set of all integers, which contains the set of all natural numbers. So here we go. We're going to put the icing on the cake here. Every natural number is at the same time a natural number, an integer, a rational number, a real number, and a complex number. And any natural number is all of those things. So that means the only answer choice that we can even look at here is the one, let me find it here, is the answer choice that contains every single option, which is answer choice E. So E is your answer to this question.